If you're watching and have questions, please post them as a comment on whichever platform you're watching on. We'll answer live if time permits. Today's episode is all about encoding and packaging, and we'll be discussing the GPAC open source technology framework recently licensed by Netflix for their live streams. Specifically, I'll speak with Romain on his birthday, and he's a main contributor to GPAC and the founder and CEO of MotionSpell, the licensing arm of GPAC. And the reason we're talking with Romain today relates back to an experience we had with FFmpeg here at NetInt. We started doing some testing with some of our cards, and the cards performed well up to a point. When the FFmpeg operations became more and more complex, we saw that the throughput dropped significantly, even though capacity in the cards and capacity in the CPU was fine. So we started researching alternative solutions. We found Gstreamer, and we also found GPAC. Romain was kind enough to join us today and talk about these and many other applications of both programs, and just describing the technologies, where they fit, what they perform, and how to consider which ones to use for your application. So let's start there. Romain, thanks for joining us.
Thank you, John.
What are you doing for your birthday? Anything special?
Yeah, there was, we were doing something this morning for breakfast, but after that, I don't know. Maybe a surprise for me.
Yeah, I guess you're in France, or you're off an island somewhere.
Yeah, I'm on a French island in the Caribbean.
Okay, so you're saying we're not keeping you for anything.
Yeah, that is EST is time.
Okay, perfect. So why don't we just jump into the FFmpeg issue? What's going on with multi-threaded performance with FFmpeg? What are the symptoms? What are the causes? And how do we work around it? And take it a bite at a time. Don't try and jump into all that.
Okay. So first, maybe so we're going to talk a lot about multi-threading. So first, what is a thread? So a thread is a sequence of instructions, that things that you want to do sequentially. So you cannot do them in parallel. If you want to do this, if you want to do things in parallel, because you have many cores on your computers, for example, so your computer is able to compute in parallel, then you need to have several threads. And these threads, most of the time, are not all the time, but most of the time are said kernel threads. It's an object that is understood by the kernel of your operating system that's handled by a component that is called the scheduler. So the scheduler analyzes which threads are running, which threads are eligible for computing, and it handles all of that. So okay. Maybe more specifically on FFmpeg for your question, FFmpeg is a multi-threaded application. And so there are several levels where it's multi-threaded. There can be like a codec that can be multi-threaded when you execute, for example, x264 or x265 as a library inside FFmpeg. They create their own thread, but also FFmpeg creates its own thread, the application FFmpeg.
Okay, so what was I experiencing when we saw a drop in throughput with, and let me just, typically the operation was large file in, say 4K, and then a pretty complex encoding ladder out, say 5 or 6 rungs, and testing HEVC because it's 4K output, and H.264 doesn't make sense. What's happening in a it's a pretty simple command line, right? We do it all the time, but what's happening that causes throughput to drop?
Okay, so it's not an easy question. So first, I think there's been an effort in FFmpeg to try to bring more threads at the application level. So that's what I was saying. There were not so many threads. I think in FFmpeg 5, one of the big changes is that now when you have multiple outputs, each of these outputs run in a separate thread, which means that, for example, if you have 2 outputs connected to 2 different servers, is there is a problem on one of the outputs, the second one is not hung. So they can run in parallel. When it comes to 4K, it's a really huge question. I think there are many factors that affect performances when you're trying to reach the limits of computers. There are threadings, of course. If you're not threaded enough, or if you have too many threads, also maybe that's something that we may want to talk about. Then you're not going to run at your maximum speed. But there is also IOs, right? If you don't deal with IOs correctly, then you can be limited by your IO, so the input-output. And there is also some memory issues. For example, so we're going to compare maybe with the other frameworks, but in FFmpeg, the queues are really large. If you queue a high number of decoded frames that are pretty large by themselves, then it can take several gigabytes of memory. So RAM is cheap, but if you don't have enough RAM, then it's going to write to the disk, and then it's going to be super slow.
Interesting. How do you mitigate that? And if you're working with a command string as opposed to, I guess more programmatically, is there any way you can mitigate against that?
Yeah, that's a good question. I think so. FFmpeg is two parts, I think, for most of the people. There are some libraries like libav codecs for the codecs, libav format for the demuxers, muxers, network protocols, and a bunch of others. And then there is the FFmpeg application. There are other applications in FFmpeg. There is ffplay, which is a simple player. There is ffprobe to inspect your content. And the efforts that I was talking about are on the FFmpeg part, which means that other people were able to leverage some of the benefits that the FFmpeg developers are trying to implement, because they directly integrated the FFmpeg libraries. So when you consider big companies like Vimeo, YouTube, or other projects like GPAC, we integrate the libraries, and we could investigate with some improvements on the performances. FFmpeg is really great for this because you can plug at many points, like for the IOs or for the memory allocators or for the threading, and you can do your own stuff. Not everything is solved on the FFmpeg side, but as I said, they've been working on it. So exciting.
Okay, well, version 6 came out right in the middle of these problems, and I basically just used the same command lines and tried on version 6, and I found no difference. So, I had thought that one of the goals with version 6 was better multi-threaded performance. What happened? Am I just, what changed between 5 and 6, and why didn't I see any performance difference between those two versions with these type of encoding projects?
Okay, yeah, that's a bit technical. In version 5, as I said, they have separated the different outputs. So now you can run several outputs in parallel, and if there is a problem on one, then it's not going to create problems on the other output. In version 6, it's a continuation of this, and they've been working on this for at least a year. I could find commits related to better threading in FFmpeg, and at the beginning of the year, the FFmpeg developers at the FOSDEM open source conference said that the effort would last for the whole year. So probably you will need to test with FFmpeg 7 next year.
Okay, you talked a moment ago about too many cores. Go into that, and then maybe describe how machines, how you should configure an encoding machine better for 4K as compared to, say, 1080p type projects.
Okay, so there are maybe many factors on this. If you put too many threads, the problem is that in your operating system, in the kernel, in the scheduler that we talked about, then the scheduler says it's called preemptive. It allocates you with slices of time, typically tens of milliseconds. And each tens of milliseconds is going to look if there are some new eligible tasks so that everybody can have some time to execute. If you put too many threads, there are two kinds of problems. The first one is that you switch all the time. It's called a context switch. The price is pretty low, but each time you have to save your registers, you have to save a bunch of stuff and switch to the other threads. So that instead of spending time doing some computation, you're spending time switching tasks. And the second problem is that most of the time we are CPU bound. And so we rely heavily on caches. And when you change cores, sometimes you break the cache. And so again, you have a performance penalty but this is something that is really, really difficult to measure.
Okay, so can you give any advice at all? I mean, if I'm doing, say let's stick with software because, that's the most generic case, but if I'm encoding 4K videos, is there a benefit to going to 128K or 128 cores, or should I stick with 32, or does it matter, or, more jobs, less jobs? What's your sense of the best machine for, high volume 4K transcoding? Again, VOD is a lot.
Yeah, that's a very good question. I think the number of threads on your computer should be a couple of times the number of physical cores that are available on your CPU. And if you make some, graphics related to this, you're going to see that it scales almost linearly up to a certain point. That being said, it also depends on the application. As I mentioned, there are, codecs can create in FFmpeg. FFmpeg, the application creates its own codecs, but then the application may create their own codecs. You have codec-specific options, for example, for X264 or X265 or, AVC, HEVC encoding, or, any encoder where you can try to tune. So most of the time, the encoder themselves provide an automatic parameter so that it tries to scale by itself, because only the application knows if it scales, better with, twice the number of cores for the number of threads, or just, the number of cores plus a certain number, because they use this for, scheduling or whatever. And again, as I said, it's not only CPU cores. If you saturate your bandwidth for the memory, if you saturate your IOs, for example, because you're reading from the network, or you're reading from a disk that is not fast enough because you launched several tasks at the same time, then it can be a problem. That's really, really measuring performances is something that is really not easy. And sometimes with small changes, like going from, FFmpeg, the application, to another framework that uses FFmpeg as libraries, you can see big differences.
Okay. Just kind of an aside, I recently did some work analyzing the CPUs that were available on AWS. So I looked at Intel versus Graviton versus AMD. What's your sense of, what I found was that Graviton was best for X.264 and AMD was best for X.265. Are those general conclusions you can reach, or do you have different thoughts as to which CPUs do the best job with those codecs?
So I can say that we use a lot and we advocate for, Gravitons and equivalents, because they are more power efficient. And also that's because the FFmpeg developers developing the codecs they've made for years a tremendous job in, implementing all the assembly acceleration that were needed.
Okay. I mean, I found that true with X.264, but X.265 was very bad with Graviton, and that was including a very new version from Multicoreware that actually improved performance by 300 or 400%. So, any comment there?
Oh, very different projects, right? X264 is really community-based, passionate people, and X265 is maintained by Multicoreware. And even though there is passion in companies, especially on video codecs, people are, you can have really interesting discussions with them. It's not the same, right? You're in front. X264 was made by people that were, genius. I would say even crazy at some point. So for me, totally different perspective.
Okay. What about compiling different versions of FFmpeg for the different CPUs? Do you need to take it to that level, or is that not necessary?
I don't think that's necessary, but yeah, you could do this. We see, you always have problems with operations, like operational problems. So you can come into a situation where you need to have several builds or using several versions even of a specific tool. That's a possibility, yes.
Okay. So let's transition over to GPAC, and let me kind of set it up. I mean, I know FFmpeg. It's really good on the encoding transcoding side, a little bit less good on the packaging side. We use Gstreamer as kind of a workaround for some of the bottlenecks that that I described a few minutes ago. That worked pretty well. And then everybody I've known you for years and known about GPAC for years, but you really came to prominence when Netflix licensed the technology for their live streams. Give me an overview of, just really high level about where you see those three projects, including, FFmpeg, Gstreamer, and GPAC. What they do, how they fit in together, what they're good at, what they're not so good at.
Okay, wide questions, and you mentioned many things at the same time. So FFmpeg, as I said, there are the libraries, and these people are implementing codecs, protocols. It's a really nice toolbox that is really complete. There's been a huge effort on it. Really successful project. I would say critical infrastructure for the industry today. And then there is the FFmpeg application that people use. People like it because the interface is quite stable. You can reuse a lot of your command lines from years ago, and they still work, which is not the case at the library level, where you have to implement the API, which is the interface at the coding level, and it changes from time to time. So that's more work to go on the libraries. You can get some of the benefits. For most people, you can use the FFmpeg command line libraries. GPAC, so we're also implementing some standards and some streaming protocols. So we're really experts on this: demuxing, muxing, packaging, encrypting, streaming. We are active at standardization. So we have a lot of R&D. That's the difference, for example, with FFmpeg. And inside GPAC, we have our own code, and we integrate it with other libraries, and FFmpeg is a big one for us. It's a big dependency. And we leverage a lot of FFmpeg for our customers, our users in general. Gstreamer is more like an aggregator. There is no real code being implemented in FFmpeg, even though it has changed over time. But its ambition is to aggregate everything into this kind of what they call elements, which are kind of modules that you connect together in a big graph. So Gstreamer is really good at this. You mentioned that Gstreamer, could handle some of the bottlenecks that you had with FFmpeg. The framework is really more complex. And for example, we were talking about saturating the memory. Gstreamer has nice mechanisms for this. It pre-allocates the buffers. It never allocates on the fly, which is also something that FFmpeg or GPAC do. But with Gstreamer, when you have a queue, a buffer, when you are high in the buffer or low in the buffer, it's going to emit a message. And so I was talking about the scheduler. This is something that is important. At the Gstreamer level, they can decide to execute or to not execute some of their elements just because the buffer level is high or not high. And so you avoid saturating, for example, your memory usage or whatever, because when a buffer is full, there is nobody that's able to push data to you, for example. So that's a precise example of where Gstreamer may have better performances. GPAC is also quite flexible, and we have all kind of, I think, intelligent mechanisms to try to handle performances in the best way. But again, it's magic by default. There is a lot of automation, and if you don't like it, you can disable it, and there is a lot of flags to try to control your performances depending on the whole environment that GPAC may not be aware of. It's not like when you run these tools, there is no something that is benchmarking your system and then says, okay, the best flags for you are this or this. It's just saying, how many CPU cores do I have, or how much memory do I have? And it doesn't consider the fact that you're running a browser at the same time, using already a lot of memory or other considerations.
Okay.
So maybe your question was also about Netflix, and what is the question exactly?
Well, let's look at the individual, I guess, components of what I want from an encoder packager. I mean, it feels like, again, FFmpeg is very strong on the encode side, and it's very usable, very accessible. Pretty weak on the packaging side, and I guess it's, FFmpeg is over here. I don't know where Gstreamer is on packaging. I know that you're pretty sophisticated there. I know there are projects like Bento 4 that are primarily packaging. So, just trying to understand that, and I think you've given us a good start. What can you tell us about Gstreamer's packaging capabilities?
Yeah, as I said, they write little code. So basically, they're more of an aggregator. So, they don't have a GPAC integration, for example, and most of their packaging relies on FFmpeg. So mostly they have the packaging capability of FFmpeg with a few other components on WebRTC, etc., where, they have their own, they wrote their own code. But otherwise, I think that Gstreamer has some particular, markets. It's more on the hardware side, which is why I'm not surprised that a company like NetInt would try to use it. But when it comes to pure software workflows, I think FFmpeg is way, way more popular. And it's been years that we've tried. So historically, GPAC is more about file-based packaging with MP4 box. So MP4 box is the main tool of GPAC. But then people had to, encode their content with FFmpeg, dump it, and package it. I think it was okay a couple of years ago where people wouldn't trust open source software to do some live. But now things have changed. So it's really difficult to be integrated as a third party to FFmpeg. I hope that we can, change that in the near future as near as possible for me, because, FFmpeg is super popular. But we decided to do the reverse. We said, okay, we can build something that we think is leveraging FFmpeg and which is better than FFmpeg. And so we have a new application in GPAC, which is simply called GPAC, like the FFmpeg application in FFmpeg, that allows you to build, complex workflows, and it's used for live by, by many people. We have a lot of users on this. And as I said, because we're doing some standardization and a lot of R&D in GPAC, it's not only, it's a mix of a lot of things. It's a player, it's an analyzer, it's a content, generator, so you can encode, you can package, you can stream, you can dump. We embed an HTTP server, so it does a lot of things.
Okay, taking a step in a different direction for a moment, what are you seeing on the packaging side regarding utilization? I mean, we've heard about CMAF for years. We know Dash, we know AHLS. What are you seeing as trends in packaging utilization among the people that you're working with?
Okay, so yeah, I said that we were doing standardization. We are advocating for ISO BMFF. So that's the MPEG-4 file format. And so I think because we are in standardization, because it's pretty active, because they have this open source software like, GPAC, when it comes to open standardization, MPEG systems and the MPEG file format are really, really, really powerful. ISO BMFF is everywhere. The QuickTime file format on the production side, CMAF, fragmented MP4, everything that's related also to encryption with common encryption, Dash, HLS, that's fragmented MP4, CMAF. For storage, there is MP4. I think there's a huge consensus, contrary to what happens in codecs right now, where the situation is pretty fragmented. That's the same for input contribution protocols, where people still use RTMP, they use also SRT, but they don't know exactly where to move. When it comes to file formats, it's pretty stable. ISO BMFF is everywhere. And I believe that GPAC is the best tool, but again, you can try it. It's open source. There is a lot of nice features, I think, that people are not so aware of. If you take a raw H.264 file, for example, or H.265 file that you dump from your encoder, if you package it in MP4, the MP4 is going to be smaller than your input, because we eliminate all the redundancy. And in addition, you can get some, indexation of the content, and you can, have a lot of nice features that come with, packaging your content. So I think the future is ISO BMF.
Well, how does that translate to HLS, Dash, or CMAF? I mean, does that mean Dash, or it feels like HLS is still the leader, years after standards-based approaches became available. Are you saying that's not true, or? I don't remember what Bitmovin said in their developer survey. I haven't looked at that in a while. But people they have to output one of those packaging standards. What are you seeing in terms of support?
HLS has dominated for years. It's going to continue to dominate. Yeah, but that's
Okay.
the truth. But it's not important, right? The way you handle your manifest is just a really tiny part compared to what you're doing with the rest of the data, which is, the majority of everything. And then there, again, there is a convergence on CMAF, which is ISO BMFF based. So I think we're pretty close now that there is a convergence also on the encryption, because that, everything that was, industry based was AES, CTR, and Apple said, okay, but CBC and CBCS in particular are, where we want to head to. So there is a consensus right now to go to CMAF, and for the encryption, CBCS. So I think the convergence is here. We are really near the point where you would have only one media format to distribute.
Okay. And that is ISO BMFF with different packaging, and that's the whole promise of CMAF is, the manifest is such a small portion of it, it really doesn't matter.
Yeah, but I understand that for people it's it's messy, because when you consider, so I say ISO BMFF, which is maybe a technical term for most of the audience, that's the base standard that is edited at MPEG. And you can imagine that CMAF is a profile of it. So it's going to restrict the toolbox. I would have liked it to be restricted to a point where you say, okay, I need to package this, and you know exactly what's going to be out, like we have for bit accuracy, like we have for codecs. When you take an encoding stream, you know exactly where you're going to have as an output. It's not that true anymore. There are a few discussions on that, but basically that's what you have. But still with CMAF, not restricted anymore. So there is a lot of freedom, and when there is freedom, of course, interoperability is much, much more difficult. But again, in GPAC, separate from the main GPAC repository, we have a repository called Compliance Warden. And the Compliance Warden is all about compliance on ISO BMFF. And maybe one day we'll get some sponsors to have the full ISO BMFF and CMAF stack, so that people can actually have some better compliance on this.
Okay, so let's take a deeper look at GPAC. You said it's open source. You said it's command line. Codecs that it handles, pretty much the standard, H.264, HEVC, AV1. Any limitations there?
No, a lot more. You can mix. You can mix everything. All codecs. You could dash any codec. You can dash also Matrovska, WebM. Whatever. You can put special flags to be interoperable with basically everything. That's the chance we have. We have pretty big users, not only Netflix, and it gives us wide range of application and interoperability. I think that a lot of people, because we're doing R&D, for example, VVC, we've had some integration with VVC for 3 years. So basically, when you want to package VVC, there is a high chance that you come to GPAC and you try GPAC. So it's not a real strategy from us to try to attract users, but this is something that is pretty effective compared to other packagers. You were mentioning Bento 4. So Bento 4 has only one maintainer who hasn't worked in packaging for like 6 or 7 years. So for me, there is a lot of packaging projects that are really good, used by the industry, but there is a real risk when you have only one maintainer and the project is not actively maintained anymore. So that's why we were talking about that. There are different strategies, I think, in open source, and projects like FFmpeg or GPAC, they come from a real pain point from users, passionate people who, that's my case. I needed this solution. I started to contribute to GPAC, and then I made a company because I'm passionate. I think people can see that. I'm passionate about it. I try to find a way to make it a living. And also with GPAC licensing, the commercial arm of GPAC inside MotionSpell, to allow other people also to, be able to live off their contributions.
Okay.
FFmpeg, they have the same, right? They have FF Labs now. They had a booth at NAB. And for Gstreamer, there were these two companies, Fluendo and then Collabora. I think that's really important to give the industry confidence that, they are real people, supporting the project and understanding their needs. It's not a bunch of teenager kids, in their garage, because sometimes that's the feeling that you can have if you go, for example, on the FFmpeg bug tracker. You can be, have a wrong image, but still they are trying to build something for the industry.
Yeah, I mean, they're tremendously talented programmers. What about, so looking back at GPAC, what about HDR? I mean, Dolby support's huge, HDR 10 Plus is huge. What are your capabilities there?
Yeah, we support everything. We have a very generic support, and the latest release that was last December had a special focus on HDR. So we support everything: static, dynamic metadata, all kind of metadata. You can re-inject your own metadata. You can fix the metadata along the stream, because sometimes there is a lot of streams that are just broken. Let's frame it this way. So we support everything, and again, we have a really deep integration with FFmpeg's internal that allows us to take like the raw, the matrix coefficients and the color space, etc., and to map it into something that would be recognized as Dolby Vision or HDR 10 or HDR 10 Plus, etc. So really good support.
Where does the Dolby licensing come in? And I guess taking a step back, can I do Dolby Vision with FFmpeg? I know I can do HDR 10 Plus, but can I do Dolby with FFmpeg? And what about the licensing? Is that just device decode side, or is that on the encode side as well?
Yeah, but I don't know. I know they support it on the encode side. They support the metadata, like, they have some special side data that comes with the packets of the data, and they support it. That's all I can say. I don't know more about this, but that's sufficient for GPAC to package it.
Okay. One of the things that's kind of been interesting to me is the compare and contrast for commercial software, like you can get from a number of vendors. Harmonic comes to mind. What are the pros and cons of open source versus buying a commercial version that's going to have a pretty extensive UI? It's going to have a lot of testing. It's going to have people you can call and get support from pretty easily. What's your sense of that decision?
Well, I think there are several reasons why you will want to do that. I had the chance to talk at NAB, at the NAB Streaming Summit with Netflix, and they explained that they do it first because it's open standards. They don't see how they could compete on this. It's not their goal now. They are pushing contributions there. They want to compete on other things, not these open standards. And I think Netflix made a demonstration when they migrated to GPAC. They moved super fast. Like you see Bandersnatch, you see evolving a new generation audio codecs. They announced an ad-based tier. They moved to live. I don't know any company able to move that fast. So I'm not saying it's 100% because they are using open source or whatever, but clearly that's points where packaging is crucial, right? How do you make sure, if you're doing interactive, how do you make sure that you can stitch your content? Do you know any commercial tool that says, okay, I can stitch and create scenarios on this? If you don't control exactly what a packager does, you cannot do this. So, and again, when there is new codecs, when there are other things, using an open source tool, you can leverage the work that has already been done by the community. So I think that's important. But that being said, Netflix is a pretty innovative company. So we have the chance to have them like as sponsors, and also they pay us when they need integration of new tools, new codecs or whatever. For us, it's really easy to work with such a company, and we understand that it's kind of easy customers for us, easy users for us.
They've got
power users and contributing.
I mean, they've got a phenomenal engineering team, and I guess certainly a lot of publishers don't have the engineering resources in-house that Netflix does. But let's move to Netflix. Tell us what it is you license to them, and what it's being used for at Netflix.
Yeah, I think they gave a number. It's like, what was it? It was 1 million. I don't remember the scale, but that's millions of content every month that are being packaged. Basically, they package everything. They mentioned that as I said, on the production side, they handle the content, or at least some of the content with GPAC, because they don't control 100% of the the formats that comes in. Also previews for the journalists. packaging the content for their 200 million viewers. So my understanding is that they package everything. But again, when it comes to open source, the magic is that you don't know what your users do. We don't put telemetry in our tools. That's pure freedom. So I don't know what Netflix is actually working on. If they don't send me an email, or when we work with customers, we have acceptance tests. So that's test basically that we both execute. So that Motion Spell for GPAC would execute and Netflix would execute, and we agree that this shouldn't be broken. Otherwise, there would be a problem. We send them an email, or when they want to upgrade their version of GPAC, they would have to execute this list of tests to make sure, to give them confidence. So that's the only way for us to know how a customer actually uses GPAC.
Okay. So is it for live? Is it for live and VOD, or you just don't know?
I don't know. I know for VOD for sure. We were not able to talk about live for the NAB presentation, but I hope that, if there is some GPAC involved, we can also share things. They have a really great technical blog, like many of the companies. And so it would be great if they could communicate on it, but, I don't know, maybe this needs to mature also. I'm not into, as I said, Netflix or any other customers internal. We're a pure technical vendor.
Okay. So, I mean, that leads me to the whole, open source versus for fee. And I mean, how does that all work? It's open source software, which means I can use it. iJanos can use it for anything I want. How does it evolve that I end up paying you? Is that something I have to do, or is that something I may want to do to get support, or how does that work?
Yeah, okay, so that's something that you may want to do to get some support. You may want to support us also. If you use us and you're successful, you may want to support us so that the project continues, is sustainable, basically. But there are sometimes the open source, the GNU LGPL license is a bit tricky for companies to deal with. Like you cannot forbid reverse engineering and these type of things that you look twice if you want to accept such clauses. So we're in a position to do a license GPAC, and so we can emit commercial licenses. But it's these licenses. It's not. We're not looking specifically into details. What is important for us is that people have a solution. We're building really a platform, and I'm pretty sure I have all the statistics. Of course, I'm pretty sure GPAC is going to be it's a majority of the packaging now is done with GPAC. And so I'm pretty sure, as I said, because we're on open standards, I'm pretty sure that there's not going to be a lot of competition on this. I think it's going to stabilize. We have ISO BMFF, which is a really good technical basis. And once the innovation slows down, and I think it's going to happen on where we are. I hope so. So there's still the question, as I said, to the contribution protocols. We're not on it, and there is a real problem. There is also the problem of what's going to replace MPEG TS exactly. So now we went into HTTP delivery with OTT, and ISO BMFF is pretty good, but that's not a streaming protocol, right? So there are still things I think to figure out on the transport level, but that's the future. I think ISO BMFF is going to stay. Is going to stay for 20 or 30 years. And after that, who knows?
Okay. Give me the compare and contrast with Bento 4, because it seems like you extended back into FFmpeg for more of the transcoding operation, but that primarily you're being used as a packager. Is it Bento 4 your most, I guess, the most pressing competitor at this point, or the one that's most obvious?
I think a lot of people in the industry use Bento 4. Some of them realize that it's not maintained anymore, and that's a technological risk. So, but that's not the only risk that they face. As I said, it's a problem. You go into open source, and then the project is not maintained anymore. You're happy with the project, but then there is a new video codecs that appears. Who's going to implement this? If you have nobody to coordinate the developments, what happens? So I think, again, that's what I think a lot of people like GPAC, and they go to see us because there is an active community. It's an active project. We are always ahead of time. And everything is easy, everything is flexible, there is a commercial arm. So I think that maybe the next move for us is also to help customers to migrate from Bento 4 to us, just because at some point there is no solution. There is another competitor, pretty big, in the same area, that's Shaka Packager. Like the two main maintainers are not working on it. There is a lot of people who came to sales and said, what do we need to do? It's a Google project. We need to de-Googleize it. And then we need to maintain it. And when there are new codecs, who's going to do this? Even for big companies, there is no inside resources. Netflix is the proof of that. They had their own packager and they decided to move to open source. And then some of the companies who went to the wrong, they couldn't know, to an open source project that is not maintained anymore. Now, what do? Either they invest on something else like GPAC, or they need to maintain the tool that is not maintained anymore, or create a community around it or whatever. So I think it's also our responsibility to help people migrate easily to us.
Okay, I should note, I mean, I went and I'm doing a talk at Mile High next in a couple of weeks, and I looked at there are some responses to questions posed on the Bento 4, whatever the resource is for support. I don't know if there's any new development. There have been responses within the last 2 or 3 weeks. So I don't know what that means. I just want to mention that because I don't want to. I'm not saying it's not better to switch over to your tool. I'm just saying, there are signs of life there that may be different than what it is you're expressing.
Yeah, I think people can. Yeah, there are things that you can have a look at, like how many open issues in a project, how many pending pull requests. It gives you, a sense of, is the project active? Are the people, are there enough people to, deal with the activity of the project or whatever? I think that for people, comparing open source projects, most of the time they are comparing the stars, which is on GitHub, when the projects are on GitHub, which is a good indicator of the popularity of a project. But then look at the open issues.
Okay. What about, I'm actually looking at GPAC now to integrate into the same talk. What are the educational resources that you have? That's going to be important both for new implementers and for people switching over from Shaka and Bento 4. How developed are those capabilities on your website?
So, okay, the website is pretty old. It's just, it dispatches users. That's that's all it does. We have a pretty good wiki that's hosted on GitHub. So if you make searches on GitHub directly, you can find a lot of things. And if you read the README, in the front page, we give a lot of pointers to our test, our build boat. There is a Doxygen for developers. But yeah, again, I think the wiki is the best entry point for people. And then on the command line, we have some really good magic. If you make GPAC -H and you put whatever word, it's going to output everything that is related to this word. And by reading the doc, you will learn that we have several level of verbosity on the help. So as I said, we want to make it magic. I think that for a lot of people, command lines can feel painful, and the learning curve is really, really important. What I would like is that in the future, we have a graphical interface. I think that would be great for people to see, what's happening, etc. Because multimedia is a lot of magic. You have H.264, it's Annex B, and then someone has to take care of this. That's the same AAC, implicit signaling, ADTS, LATM. That's a nightmare. When you don't look into the details, it can be a nightmare. And I think people would, educate themselves by having to, some, graphical interface showing to them what is the actual work that's being done. And I wouldn't do that only for users. I would do that so that, we can also, keep talents and, make it less, less complex. I think talent is, how do you say, talent retention is something that the whole industry should look at, because there is a lot of, gifted people leaving our industry after a couple of years, and we need more of this.
Okay, we have a question. Can you describe the extent of your VVC support? And I guess VVC, I know Fraunhofer had an issue with getting their VVC implementation into FFmpeg. So which version are you supporting, and how does that work?
Yeah, we're pretty up to date because we are we have a close integration with the people of OpenVVC, which is an open source VVC decoder. They have some integration in FFmpeg, and so we're following the latest developments of the standard. If that's not the case, just open an issue on our bug tracker, but we're pretty up to date. There is MPEG this week, and so we're going to make an update if there are fixes to the spec or additions.
Okay. Another question on your inspector. What can your inspector do, and how is it different from, say, media info?
Yeah, okay. So I think media info is a great inspector. It's you take media info, the name of the file, you can go command line, you can go with the graphical interface. It gives you immediately an overview. But one thing that it doesn't do is inspect the packets, like deep inspection of each of your packets. And GPAC does that. We have several levels of verbosity, and so it can display general information. And I would like, as I told you, that I want to improve that, maybe a graphical interface so that people can navigate into the content. And then you can go deep, 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 up to the point of every bit that's been parsed. That Netflix had they had an anecdote about this, that GPAC was really, really picky and really going really deep in the bit streams. And actually it was reporting, or they were able to report errors on some standards where files were already widespread. And then you have, what do you need to do in this situation? Do you need to modify the standard, or do you need to ping the other implementation and say, hey, you should modify what you're doing?
Okay.
So deep inspection.
One last question. What is motion spell? I think you mentioned that at the start, but and we just got a question in that relates to that, is what are the licensing terms for GPAC and FFmpeg? So what is motion spell, and what are the licensing terms for GPAC and FFmpeg?
So motion spell is the company that holds the commercial arm of GPAC, and we're also making products, most coming from the GPAC technology or related. So we have things that are related now. We have an OTT live subtitle inserter for people having a live OTT stream, but they need to add subtitles on the top of it and they don't know how to do it. And as I said, also related to compliance, we're doing a lot of work with the biggest companies in the industry. I think that's pretty important. And regarding the license of FFmpeg and GPAC are the same. That's LGPL v2.1 plus. And my chance at Motion Spell is that I went to see every of the copyright holder in GPAC, and they sign an agreement with me, and I can put a commercial license, which is basically your terms. We propose basic terms, and you can modify them to suit your needs. So it's pretty flexible.
Another question came in. What's the status of mp4box.js? Is that being maintained?
It's not actively maintained, and I think that's so. Now it's not true. We're in the same situation as Bento 4, right? We're merging the pull request, but we're not actively developing it. And there's a reason for that. There is WebAssembly now, and you can build GPAC and run it in your browser. So I think it's going to be deprecated within a couple of years. That being said, in the middle, I think mp4box.js is a really, really nice tool that's really popular, and people use it coordinated with web codecs, and they can transform their content in the browser. That's really amazing.
Okay. Well, why don't we call it a day after that? You can go on and celebrate your birthday on your Caribbean island. And we'll let the audience go back to their day as well. Listen, pleasure seeing you at NAB, pleasure working with you on this. And, I'm sure we'll be in touch over the next few. I'm going to need some help with the presentation I talked about. I'll be in touch, and thank you for participating today.
Yeah, my pleasure. Thank you, Jan. Thank you, everybody, for attending. And if you have questions, I'm always here. Thank you.
Okay, take care. Bye-bye.
Bye.